Hello and welcome to Sudoku. Here is a Renban Sudoku puzzle that was set by Dutch creator Wilbert Zwart for the round 5 of Sudoku Grand Prix 2021. And the rule of a Renban Sudoku is that whenever you get a shaded region like this, all digits must be different and must form a consecutive set. Meaning that this, for example, let's just disregard the digits around, could be, let's say that. Of course, it doesn't work with the digits that are given, but that's the idea. 2, 3, 4, 5, 6 form a consecutive non-repeating set, and that's the point. In this puzzle, there are two Renban regions of 9 digits, so they must contain exactly all digits. And during the contest, I didn't solve the puzzle. I gave up in the middle, and that was a bit distressing because when I came back to it, I solved it in a matter of 3 minutes. I mean, not the whole puzzle, but the point where I was stumped. Okay, let's begin with this row. 3 goes there, 8 goes here. 7 goes here, which is interesting because we know that the digits are consecutive, and we see that there's no 9 in here. There can still be an 8, so it could be 8, 7, 6, 4, 5, 4, or if 8 is not in this region, then it will have to be 7, 6, 5, 4, and 3. And both options are still possible. If this is with an 8, then 8 goes there. If this is with a 3, well, 3 can go anywhere. But we know for sure that 6 is in there, so 6 has to go into this cell, and 5 and 4. So 4 is somewhere here, and 5 is somewhere down there. Oh, and now we know that 6 is here, 8 can't go here, so the last digit is a 3. So I just mark 3, 5, 3, 4, 5, and the remaining digits in the column must be 6 here and 1 there. 6 has to go here. And where do we look next? 8, 8, there's an 8 here. This 4 and this 4, put a 4 here. So this one is either 3 or 9. Here the digits are 2 and 9. And at some point I have to really think in terms of what do we do with those extra regions, because that's really what is called extra region. So for example, let's have a look at this region and digit 4. 4 is not here, it's not there, it's not here, not there, it's in one of those two cells. There's a 4 down there. Something interesting, we still need 5 and 6. They are not here, so this can only be 2 or 3. Now it can only be 3 actually, that's the only option for this cell. So we have a 2 here, so this is a 9, that's a 2, that's a 3, 2, 5, and 6. And this 3 is nowhere in the shaded region, it's not here, so it has to be on this diagonal. Something else of interest is this cell. we know that those are the 9 digits, and the shaded region also is the 9 digits, so this digit is the same as this one. And it's not 2, 3, it's not 4, it's not 8, it's not any of those, so it has to be 1 or 5, I think. 2, 2, 3, 4, 6, 7, 8, 9. Yes, this is 1 or 5. And it's the same digit here. And interestingly, this digit that is here and there must be down there. So it's either this one or a 5 that would be here. And both look possible at this point. So where is the next place to look? Here we need 8 and 9. Here we need a 2, which is not here but there, and 1, 5, and 6, and actually I should have noted that this 6 goes there. This 4 goes in one of those cells. Eight, 8, 8. We get an 8 up there. And we get an 8 on this diagonal. Let's have a look at this. And let's ponder this digit. This digit obviously is not there, but it's not in the shaded region. So this digit has to be here or there. So it can't be a 2. Oh, sorry, it can't be the 2 here. No, that was bad logic. This digit is not here or there, so it must be in one of those 4 cells. That was really bad logic. So here 1, 5, 8, and 9. What about this digit? This one is really interesting because this one is not here. It's not in the shaded region, so it must be up there. It can't be a 2, it could still be an 8. So it's either this 8 or this digit. And note that this couldn't be a 3. So if this is a 3, then 8 goes here, which is rather interesting, but not really useful, I'm afraid. So I must be at the point that stumped me, or perhaps this is 3, 4, or 5. Let's have a look at this column, perhaps. Let's have a look at this one. Could one be here? If one is here, by the Renban logic, we must have 1, 2, 3, 4, 5. So with the 1 here, we must have 4 and 5 here, which is not permitted. So 1 is not here. 1 is here or there. And what about 2? 2 is here or there. And I think the logic is the same. If 2 goes here, then I must have a 4 in this Renban. Oh, there's no 4 in this Renban region. And with 5 digits without using 4, it has to be 5, 6, 7, 8, 9. So, okay, this is what I've been missing. So this 2 goes at the bottom. And those are the high digits. So 7 is not here, not here. Well, how do I do this? That's a valid question. 6, there's a 6 in one of those two cells. This is 5, 8, or 9. 5, 7, or 8. This one can only be 5, 8, or 9. And then what? And then what? And then I'm not sure what. That's the confusing part. This here is not 2, 3, 4. Bobbins. I was thinking that this digit is not here. If this is an 8, and then I get an 8 here. No, that's not. Oh, where is 8 on this region? That's a good question. 8 is not here, it's not there, so it has to be in one of those two cells. That's what I was missing. So this one is a 9, this one is an 8. And knowing that is not enough, knowing that is really not enough. What am I missing? 3 is around here. Yes. There's no 3 here, there's no 3 here, so there's a 3 here. So this one is not a 3, this one is. Not sure that's so useful. Where do I put a 7 around here? In this region, 7 is not here, it's not there, so it has to be here. And now we know that in the Renban, 7 goes here. It puts a 6 there. And we get a 7 here. And a 7 somewhere in those cells. And there's a 9 here. Let's look at this column. So this is 1, 5, or 8. And if there is a 1 here, then there's no 1 here now there, so there has to be a 1. So I think 1 can't be here. That's correct. If I put a 1 here, it removes 1 from all those cells, this one and this one as well, so there's no place for 1 here. So this one can't be a 1, and I get a triple here. A 5, 8, 9 triple, and this digit is the same as this one. And the important part is that the remaining cells must contain 1 and 6, and because of this one, I get a 1 here, a 6 there, and now 6 removes this option from those two cells and puts a 6 here. And this 2-5 pair makes this an 8, this a 1. This 8 puts an 8 at the bottom, and an 8 here, and an 8 up there. This is now a 5-9 pair, and this one gives another 5-9 pair, and we get those digits. And this one. Okay, so what is missing here? 4, 7, and 5 and 9, so this one is a 5 or a 9. And this one is the same as this one. So now we know this is not a 5. We need 3, 4, and 1. And 1 is here. 3, 4, 5, 9. This 5-9 pair gives a 3 here. And that is a 2. We still need the 9 somewhere. It's here. We need here 3 and 5, and because of this 3 we get that, and this disambiguates a lot of stuff. Well, not so much, but it disambiguates some stuff. And there we need 1 and 3. There's a 1 here. This is 9 and 6, and because of this 9, 9 and 6. Now, where do we go? We still need a 2 here. And bobbins. What am I missing? Oh, 9, 9, so there's a 9 here. The plot thickens. Let's have a closer look. So, this is 2 or 4, 4 or 7, 2 or 7. That's true. 5 or 7 here. 4 or 7 there. Oh, but this 2-5 pair removes 5s from this cell, and that disambiguates the lot. Except, oh no, not except, this now can only be a 9, and this disambiguates the 5-9 pairs across the grid, and this finishes the solve of this Renban Sudoku puzzle. And it had the same number of points as position sums, but I found it to be way more difficult than the position sum puzzles. Okay, thanks for watching this video, and see you soon on Sudoku.